Hello, today we are going to learn a couple of techniques to evaluate limits. This is section 11.2. In the last class, we studied how to use a table of values to evaluate a limit. And this technique is certainly a valid technique that will continue to work for you regardless of the problem. I mean, we can always use a table of values to graph or to evaluate limits to get an idea of what a function is doing. But there's other techniques that will certainly get us to correct answers and to allow us to solve problems. One of the ways that we can evaluate limits is with this thing called the dividing out technique. And then we will also learn a rationalizing technique today. The dividing out technique involves factoring a numerator and denominator, simplifying a problem or a fraction, a rational expression, and then using direct substitution to evaluate a limit. Okay, so let's take a look at a problem like this. Example, we'll do the limit as x approaches -1 of x squared minus 4x minus 5 divided by x plus 1. So notice that before we get started, if we were to attempt to use direct substitution as it stands, we would get -1 squared minus 4 times -1 minus 5. Whoa, this should be -1 here. So this is 1 plus 4 minus 5, all divided by -1 plus 1. So we would have 0 divided by 0, which is an indeterminable form. We could use our table with the -1 in the middle of the table and find out what happens to this rational expression as x gets really close to -1 from the left side and the right side. Or we could use this dividing out technique. So instead of evaluating the limit as x approaches -1 of x squared minus 4x minus 5 over x plus 1, let's factor the numerator into x minus 5 times x plus 1. All right, so this becomes this. And now we can reduce the numerator and denominator, and we'll be left with the limit as x approaches -1 of x minus 5. Notice when we use direct substitution of our c value into our function that's left, it doesn't cause us to be undefined, and we get -6. Another example, let's try to look at the limit as x approaches -4 of x plus 4 divided by x cubed plus 4x squared minus 2x minus 8. Again, we notice that if we use direct substitution as our problem looks now, we'll get 0 divided by 0. So instead, let's go ahead and factor this denominator into x squared times x plus 4, -2 times x plus 4. The x plus 4s will factor out into x plus 4 times x squared minus 2. So we'll rewrite our limit problem as the limit as x approaches -4 of x plus 4 divided by x plus 4 times x squared minus 2. And then we'll reduce our x plus 4's and be left with the limit as x approaches -4 of 1 divided by x squared minus 2. We recognize direct substitution does not cause our problem to be undefined anymore, and we can then get this to be 1 divided by -4 squared minus 2, which is 1 over 16 minus 2, which is 1/14.